Given that n can be any integer such that n is bigger than 1, prove that n squared minus n is never an odd number. Okay, so first thing what I want to do, guys, is always factorize the expression. So we're going to have something like n times n minus 1, yeah? Now, to prove that something is never odd, what we got to do is just more or less think of a number in our head. So let's do this, yeah? Okay, let's say n is, I don't know, some random odd number, yeah? Let's say it's like 1 or 3 or 5, etc. So if n is odd, we're going to have an odd number times, well, one number back is going to be an even number. So odd times even is odd. So here's an example. 3 times, I don't know, 2, that gives us a 6. So an odd times an even gives us an even. Okay? So that's what's essentially happening here. If you pick a number like 3, you're going one back, so it has to be 2. Now suppose you want an even number for n, okay? So let's say if n is even, then this would mean that we're going to have an even number times an odd number, and well, we don't have to do nothing because even times odd is like the example above. When you times in two different things, you're always going to get an even number. So that's it. So actually we just proved a statement. We just proved that it can never be odd. And that's it, guys. 13 is done. Question 14. Find the exact value of tan 30 times sine 60. Give your answer in its simplest form. Alright guys, so to solve these kind of problems, we always go use our right angle triangles, and if you guys remember, we need to use something called the 30 and 60 triangles, yeah? Now these are just fixed definitions, but what we need to know is that if we imagine that the length opposite 30 is 1, then we're going to have a length double it, 2, and if you use Pythagoras, you get root 3. Now I'd personally just memorize this triangle, because this is the triangle we need to learn. There's this one and also the 45-45, but we don't need it here. Now to work this one out, we need to use SOHCAHTOA, right? And we just have to basically pick the right one. So in this case, because we've got tan 30, we need to use TOA. And what that means is that we need to have tan of the angle, in other words, a tan 30, is going to equal the O, which is opposite 30. Opposite 30 is a 1. And then the adjacent is next to 30, which is root 3. And that's it. Same thing for sine 60. Sine 60 is so, yeah? So it'll be opposite the 60 angle, so it'll be root 3. So opposite 60 is root 3. And the hypotenuse is, well, is 2. So it'll be root 3 over 2. And that's it. Now, if we're going to multiply these together, what they want you to do is to actually multiply their fractions, yeah? So if you multiply their fractions, cancel the root 3 and you get a half. And we're done. Easy. Alright guys, number 15 now, yeah? So the diagram shows a solid shape, and the shape is a cone on top of a hemisphere. So guys, a hemisphere is just literally half a sphere, yeah? Okay. Now you give them some info, they give us the volume of a cone, and they give us the volume of a sphere. So because we've got a hemisphere, it's going to be half of that, yeah? Now according to the information, so just having a quick look at it, guys, yeah? We've got a radius of 3, because if the whole diameter is 6, it's half of it. And the height is 10. So and this is going to link to basically the info on the right. Now, going back to the info at the bottom, it says that the height of the cone is 10, diameter is 6, and hemisphere is 6. So basically stuff we already know. Now the important information here is that the total volume of the shape is k pi centimeter cubed, right? So if we had to work out the volume of both those shapes, the sum of it must be k pi. Okay, that's one thing to note. So just looking at the data, we can say that the total volume is literally going to be the volume of the cone plus the volume of the hemisphere. So what are they both? Well, let's go back to the formula for a second, yeah? The volume of the cone is given at the top. It's a third pi r squared h, okay? So let's just pop that in, yeah? So volume of the cone is third pi r squared h. Now the volume of a hemisphere, as you remember, is half of that. So if it's 4/3 pi r cubed, half of 4/3 is 2/3. And that's it. So writing that down, yeah? So 2/3 pi r cubed equals k pi. Now, before we move on, let's try and simplify this, yeah? It states here that the cone is 10, the diameter is 6, in other words, the radius is 3. If you drop these values in, and if we just knock out the pi's here, because look, we've got pi's everywhere, you can just like remove it now. Now we just drop in the values. So just replacing r and h with what you know. So we've got a third, and then times, what's that, 3 squared times 10 plus 2/3, and then r again is 3, so 3 to the power of 3 equals k. And now you guys can simplify it how you want, but what I will do is just try and cancel all the 3's. So you're left with 30 there. Cancel the 3 there, so it becomes 3 squared. And then you get 2 times 9, which is 18. Just sum them up and you get 48. And that's it, guys. Alright, 16. So we're given 3 dials on a combination lock. Now each dial can be set to one of the numbers. So 1, 2, 3, 4, or 5. The 3-digit number of 553 is one way the dials can be set, as shown in the diagram. Okay, so it looks like you've got 3 different ways to do 5 different numbers, yep? Work out the number of different 3-digit numbers that can be set for the combination lock. Okay, so what this is asking us is literally how many different ways we can arrange this, yeah? So for example, if you just had one digit, then if you only had one single dial, then you have 5 ways. But if you got 2 dials, then you have 5 times 5 ways. Because you got 3 ways, it's going to be 5 to the power 3 ways. Yep, so 5 times 5 times 5, which is 125 ways. That's it, yeah? Now, for this follow-up one here, it says how many of the possible 3-digit numbers have 3 different digits. So when they say different digits, what they're trying to say is that we can't repeat their numbers, yeah? So for example, we can choose numbers like 1, 2, 3, or we could choose numbers like 2, 3, 4, or even just like 3, 4, 5. However, we can't use the same number, yeah? So we can't use numbers like, I don't know, 2, 2, 3. That ain't allowed. So the number ways we can actually do this means that you initially have 5 numbers you can start with, then you get 1 less, so times by 4, and then 1 less again, and times it by 3. So altogether, you have 5 times 4 times 3 ways, yep? And that's it. And if you do it carefully, you should get 60. And that's it. Alright, question 17. So given that x squared to 3x plus 5 equals 1 to 2, so what it's saying here is that x squared is equivalent to 1 part, and 3x plus 5 is equivalent to 2 parts, find the possible values of x. Alright. So the best way to solve this question, guys, is to literally write down what we know, yeah? So we know from the statement that 1 part equals x squared, right? And 2 parts equals 3x plus 5. Now, how can we link these two together? Well, if we just look at the first one for a second, right? We can see that 1 part is x squared. How about we just double this for a second? Let's make it 2 parts, yeah? If we times this by 2, we're going to get 2 parts, which is 2x squared. Sounds logical? So in that sense, we can now say that these 2 parts must be the same, because they're part of the same ratio equation. So in a sense, if these two are the same, then that means they must equal each other. Perfect. Now what we can do next is rewrite this as a quadratic equation, because you got your ax squared, you got your bx, and you got your c. So let's subtract 3x across, subtract 5, and just make it equal to 0. And then it becomes like that. And well, to solve a quadratic equation, just use a quadratic formula, guys. And the quadratic formula looks a bit like this, yeah? Honestly, guys, you don't have to bother factorizing. When you have like coefficients bigger than like 1, like 2, 3, 4 for the x squared, I just stick to the formula because it's quick and easy to do. So looking at this formula, we just have to put in the right things. Well, the value of a represents the value from the x squared, so the 2. The value of b is minus 3, and the value of c is minus 5. So if you substitute in carefully, it will look like that. Okay, so minus b becomes positive 3. The b here becomes negative 3. You can see the a is 2 and the c is minus 5. And of course, the a at the bottom is 2. And now what I would do is just try and carefully like evaluate the surd inside, yeah? So you can see here that minus 3 positive squared is a 9. And all of these values, 4 times 2 is 8. Times a minus 5 gives us a minus 40. And because it's double minus, is a plus. So you get that value. 9 plus 40 gives us square root of 49, which is 7. So updating that, you should get that. So you get 3 plus minus 7. Now don't worry about the plus minus. All that means is that first you should add first. So for example, you do 3 plus 7, which is 10. And then 10 over 4 gives you 10 over 4. And simplifying that is 5 over 2. And if you subtract it, you can get 3 take away 7, which is minus 4. So minus 4 over 4 is minus 1. And then that's what you actually get if you did it step by step. And that's it, guys. Alright, express root 3 plus root 12 in a form a root 3 where a is an integer. Okay, so essentially, guys, we just have to more or less rewrite root 12 into terms of root 3 and then add them together and then you got it. Well, the best way to do this is to just look at root 12 and then break it down using the prime factor tree. So for example, when you take the 12, you can break it down into root 4 and root 3. And then if you break down root 4, you get root 2 and root 2. And then you just circle the last legs. And then when you have two of the same surds, they give you a whole. So root 2 and root 2 give you a whole 2. And then finally you get 2 and root 3, that gives you 2 root 3. So finally root 3 plus 2 root 3 is 3 lots of root 3s. And that's it. And now moving down to part B, we have to express that 1 over root 3 fraction to the power 7 in the form of root b over c, where b and c are integers. Okay, so straight off the bat, guys, all you have to do is basically stick the power 7 to both those numbers. So 1 to the power 7 and root 3 to the power 7. And what this means now is that we're just going to multiply the same number itself 7 times. well, 1 times itself is 1, whereas the root 3 would be root 3 times root 3 times root 3. I'm just going to use a dot so it doesn't look kind of messy. You should get 7 of them. Now all you guys have to do is to pretty much collect the root 3's, yeah? So for every 2 root 3's you get a whole 3, so whole 3, and a whole 3. And then if you times together, 3 times 3 times 3, well, the first 3 times 3 itself is 9, and then 9 times 3 is 27, okay? And then finally, collect them all together, you're basically going to have 1 over 27 root 3. Okay, so we're almost done now. So this looks like kind of a question you've done before. So here we have to now rationalize it. And to do it, we have to times up and down by root 3, okay? So we're just trying to get rid of the third at the bottom. If you times up and down by root 3, you can get root 3 at the top, and on the bottom, you're going to get 27 times a whole 3. And well, 27 times 3 is just basically, what is it? 20 times 3 is 60, 7 times 3 is 21, so you get 81. So root 3 over 81, and that's it. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications, and if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.